All right, so we continue with section 2.4, and we've graphed these this function. Yeah, I can't say this line, right, because it's actually two pieces from two different lines, right? This one from this line that goes through that way, and this one from this line that goes through. Notice the line goes all the way through, but our graph can only include that part of this one from there to there, and the part of this one from there to there. Again, remember, when I read them, I read f of x equals x plus 3 if x is greater than negative 3 greater or equal to negative 3 less than 1, and f of x equals 2x minus 1 if x is from 1 to 3, including 1 and 3. All right, so let's check to see our domain. So our domain is wherever it's the function is defined, and we can check right here. These are values of x. Remember, the domain is values of x. So this one includes from negative 3, including negative 3, to 1, but it doesn't include 1. However, the next line does include 1 all the way to 3. Okay, so really my domain is all the way from negative 3 to 1, including each of those endpoints. Okay, and if I were to I can also get that from the graph. Notice there's no graph over here. We say that it's undefined there, but then it starts being defined at x equals negative 3, right? And if I scan along the x-axis, there's points all the way up to positive 3. All right, f of negative 3, and I can get these again from the graph or from the definition. I'm going to do the definition. So this tells me x equals negative 3, and I just have to check to see where is x equals negative 3 included. Well, there it is up there, right? That means I use this definition. So f of negative 3 will be x plus 3, which x is negative 3. So negative 3 plus 3, which will be 0. F of negative 3 is 0. Notice that refers, by the way, to the point negative 3 comma 0. And there it is. Yeah, I could have found it on the graph by just going to x equals negative 3, and the point is right there. The y coordinate is 0. All right, f of 1, and again I look here. There's 1, but it's not included there. But it is included down here, right? It says greater or equal to 1. So 1 is there, not up here, right? It's here. So I use this one, so it's going to be 2 times whatever x is minus 1. X is 1. So that's 2 minus 1, which is 1, right? Notice that the point 1 comma 1 should be on the graph. Yes, it is. All right, f of 2, let's do this one from the graph. F of 2 equals, well, you go to where x equals 2, go up to the graph, and y should be 3, okay? Let's check here by using these. F of 2, where's x equals 2? X equals 2 is not up here between negative 3 and 1. It's actually here between 1 and 3. So I use this definition of the function. 2 times 2 minus 1. That'll be, that'll be 4 minus 1, which equals 3. And of course, from the graph, we got the same thing. Notice that depends on us having the right graph, though. Okay. All right. One thing that I didn't write here, but I want to know, just in case somebody asks me, like on a quiz or a test, is f continuous? And the answer is, well, if you try to trace it from left to right, you cannot trace it without jumping. Okay. I can only trace where I have graph. So when I get to that hollow dot, I have to jump. And then as soon as I jump, the answer is no. No. All right. Number 5, I'm going to leave to you guys. All right. Or to see it in class. Okay. So if you get a chance to do it, that'll be fine. If not, we will see it in class, and we will do it in class and analyze it and everything that we just did on the other one. All right. Don't forget to ask yourself, is f continuous? Continuous. That's a yes or no question. All right, let's go on to direct variation. Direct variation happens in the following way. Y is directly proportional to x, or you can say y varies directly with x. Those two are interchangeable. If there exists a non-zero number k called the constant of proportionality or constant of variation such that y equals kx. Yeah, sounds like you really don't want anything to do with that. However, all it means is that if somebody tells me y is directly proportional to x or y varies directly with x, that I should write this equation, y equals kx. Notice that's where the k comes in, right? Usually k is not given to you. Usually these numbers are. Y is directly proportional to x, and these are just numbers. Yeah? So notice you'll have number equals k times number. Notice you can solve for k. All right. Let's check to see how this works and what kind of problems we get with this, right? Because the problems don't look exactly like that. Let's check. So number 6 says, Hooke's law states that the force or weight on a spring is directly proportional to the length that the spring stretches from its at-rest position, that is, F equals kx, where F is the force exerted on the spring, or the weight, x is the extension of the spring, and k is the proportionality constant. Okay, so let's take a look at A. A says, suppose a 20-pound weight causes a spring to stretch 20 inches. Find the spring constant k. So there's something that they've done, and that is they've already written the equation for us. Usually we have to write it ourselves, but they've written it for us, right? So weight F is directly proportional to the length of the stretch x, right? So in letter A, what they've told me is that the weight equals 20 pounds, and x, the stretch, equals 10 inches. All right, so I plug that into my equation, F equals kx. Let me write the equation F equals kx. But I plug those numbers into my equation, so I will write then 20. Oh, I have to keep in mind that the weight is referred to as F. Okay, so 20 equals 10x. No, x is 10. K times 10. I'm going to write it that way. K times 10. Yeah? F equals K times x, so F equals K times 10. Be very careful, right? Notice it's not 10x. I was going to write 10x. All right. Can I solve for K? Absolutely. Divide by 10. And so I get 2 equals K. Yeah? Notice the question was, find the spring constant K. All right. Letter B says, how far will a 25-pound weight stretch the spring? So this is what I know for letter B. I know that the weight is 25 pounds. I know, I don't know the stretch on the spring, so I need to find, that means X. I don't know X. But I do know K, because I already just figured it out, and it's the same spring. So I know that K equals 2. Yeah? So now when I write my equation, F equals Kx, I write 25 equals 2x. Notice this time it was x that's missing. And then I just solve that equation. So I would divide by 2. And I would get x equals 25 halves. And I can leave it as 25 halves, or I can write it as 12.5 or 12 and a half. And AX is in inches. Do you guys remember that? It's the inches that the spring is stretched. So this is 12.5 inches. Okay? If you want units for K, and we usually don't write units, but if you want units, just go back over here and look at what you divided. This is pounds per inch, right? Because it's 20 pounds per 10 inches, so it's pounds per inch. Okay, let's go on to number 2. Number 2 says, suppose t varies directly with x. When t equals 33, x equals 5. Find t when x equals 31. It's really the same thing, just they didn't write an equation for us. How should we write it? Let's go back up here. Y varies directly with x would be written y equals kx. So here, t varies directly with x would be written t equals kx. That's correct. All right. All right. So that's just this statement. Notice how I'm taking it in parts, right? This statement tells me that's the equation that I want to use. What does the next statement tell me? Well, it tells me t equals 33 and x equals 5. So I just substitute in there. Yeah. And I'm going to leave that blank. I'm going to let you guys finish it off. That way it gives you a good opportunity to use your brains. to finish it off. So you're going to do three things. One related to each statement. The first one we already did. We wrote the equation. The second one, notice you have t and x. What do you think you're missing, right? And then the third one is really where we're getting our answer for the problem from. And then I'll let you guys see, or try to work that, or we'll work it in class. Okay, I'm going to stop here. This will be the end of section 2.4.